organic no-till corn and soybeans. So first, I'm going to give you a little bit of intro. Ben's going to talk a bit about some of our soybean research. I'll talk about a little bit more of it, and then we'll come back to Ben for some updates on the corn. So I know many of you are probably already aware of this idea of, what we call organic no-till or cover crop-based rotational tillage. But for any of you who maybe aren't quite as familiar, I just wanted to go over the general process that we do. So tillage is used to establish the cover crop in the fall. The cover crops we've been using in this research are rye, vetch, and crimson clover. We then let that cover crop grow over the fall, it overwinters, continues to grow in the spring, and then we terminate that cover crop mechanically in the spring. So as we'll talk about, we use combination. We use either roller crimpers or mowers to achieve this. And then that cash crop is planted without tillage. Okay, and so as you can imagine, there are many benefits to this reduction in tillage. So first, I think most obviously is just this reduction in tillage and labor. So reduction in fuel usage, reduction in labor, but there's also a range of environmental benefits as well. So we can think about soil health benefits, things like improving water infiltration, reducing opportunities for erosion, increasing these microbial populations in the soil, as well as the ability to scavenge nutrients. And primarily of big interest, of course, to the organic producers is this benefit of weed management. And so we grow this this cover crop with a large amount of biomass, and then this mat of the terminated cover crop serves to suppress weeds. And that's one of the big ways, and also in which sort of tillage or cultivation is reduced, is we don't need to perform that cultivation within season. And so this all sounds great, but there are a lot of limitations to this system, some of which we're working to address with this research and some of which fall beyond the scope. So I kind of divided the major challenges into two areas. So one of them has to do with termination. So one of the main challenges is that these cover crops are not ready to be terminated until a lot of times in early to mid-June, which of course presents a challenge as your planting dates are shifted. There are other challenges with not being able to completely terminate the cover crops, and that regrowth, it can present problems both in season, and those small grains can contaminate any future small grain crops that you're trying to grow. And, there's also a lot of options, and so it can be hard to know, which of these options for termination actually are performing the best, and does it really matter? And there can be some issues with in-season management of certain cover crops. So especially with respect to corn, clover is a promising cover crop, but it needs to be managed in season. And then, as I'm sure any of you who have tried this no-till strategy for organics know, that planting can be very difficult. So getting the right planting depth with that huge amount of cover crop biomass can be quite challenging. And it can also be difficult to maintain that depth with the uneven terrain. And there can also be a lot of opportunities for hair pinning, or essentially pinning that residue down within the furrow as you're planting. And finally, just being able to get that furrow closed afterwards can also present a challenge. And so with those challenges in mind, we set about the goals of this project, and we were trying to first develop termination strategies for cover crops, and second, improve planter setup. And both of these we're hoping to both increase stand and yield within these systems. And most importantly, like what we're doing here today, is we want to share this research with all of you. And so I know Erin mentioned we're working with a lot of partners. So we've got research here, some research at Iowa State, and we're also working with the Rodale Institute. We've also been fortunate to have sponsorship from Dawn Equipment, McFarland Manufacturing, as well as Albert Lee Seed. And so just a little bit of background on where we've been doing these experiments the last 3 years. So primarily the main focus of our trials have been on the Marshfield and Arlington Agricultural Research Stations, abbreviated as MARS and AARS. And we've done corn and soybeans at both of those locations. And in addition, we've also grown soybeans at several producers' fields to be able to make sure that what we're seeing on the research station also looks the same on producers' land. And over the course of these 3 growing seasons, you can see that we've had quite a variation in climate conditions. So if you look at the top one for Marshfield, you can see 2019 was quite a wet year compared to the normal here as the dotted line, whereas 2020 was a far more normal year. And you can see somewhat similar trends at Arlington, where 2019 was a fairly wet year and 2021 was a fairly dry year. And so a little bit about the cover crops we used. So again, as I said, we are looking at both soybeans and corn. And with soybean, all of our plots were looking at a rustic rye. And depending on location, we were somewhere between about 140 and 155 pounds per acre with planting dates, primarily in September. We had a few that were later, and we can talk about some of those challenges too when we get to that data. And for corn, which Ben will talk about a bit later, we used either a mix of a rustic rye and hairy vetch or medium red clover is what we've found to be. Those 2 cover crops have been the most successful to us. And we planted those typically around mid-August. And so just kind of a summary of that agronomic data, just to kind of help you understand a little bit better what were the locations looking like. So you can see here all locations over the 3 years. And so our cover crop planting, as I said, was primarily in September, but we do have a few dates in early October as well. And the cover crop biomass, there was definitely some differences across sites, and Ben and I will talk about these a little bit more and how they're relevant to our data, but we range between, about 4,000 to about 12,000 pounds per acre. And so and then finally looking, sorry, I don't know how to get rid of that. Oops, that red line. And so then we can look at our planting dates as well as our harvest dates, just to kind of give you a better idea of when these operations were occurring. So most of the planting was occurring that 1st to 2nd week in June. And again, it's hard to move those planting dates earlier because we need to terminate the cover crops at the right growth stage so that they're more susceptible to termination. So essentially, if you try to terminate these crops too soon, rye before anthesis, you can have a lot of problems with that rye regrowing. And again, harvest typically ended up being a bit later just because we did have some high weed pressure in some of our experimental plots. And so we tended to push that harvest date to much later in the season. And I'm going to hand it over to Ben, and he's going to talk to you about the first set of those experiments. We're looking at planter setup in soybeans.
All right, thank you, Jessica, for kind of laying that groundwork for why we're doing what we're doing. So in this next part of the presentation, we're going to start to look at in a little bit more detail at some of the specific research experiments we've been doing the past few years here in Wisconsin, and kind of show how they address some of these major challenges that Jessica was discussing earlier in the presentation as well. So to start off with, we'll take a little bit of a look at some of the planter modifications we've made. So again, as we talked about, when we have so much rye biomass in this thick mat that we lay down on top of the soil surface, it does a really great job at suppressing weeds, which is what we want, but it also can act as kind of a barrier to getting that seed into the soil and well placed in the soil for good germination. And so really what we're looking at in this experiment here with planter modifications is trying to see if we can make some modifications to the planter, add some attachments to it, maybe play around with the down pressure a bit. If we can get to a point where we can improve our soybean emergence, and then looking at the next question, is, does that soybean emergence have any impact on our yields as well? So Jessica, I think I'll just kind of shout out to you on the advanced slides here so you can move on to the next one. All right, so we wanted to examine 3 different components to this planter. So first of all, we looked at down pressure. We had a low down pressure versus a high down pressure. Then we wanted to examine coulters. So we used a fluted coulter and had that going for some of our treatments. And then we removed that and saw what kind of effects coulter use would have on our soybean emergence. And then finally, we wanted to take a look at the backside of the planter with a couple different kinds of closing wheels. So we used a rubber closing wheel and compared that against a spiked closing wheel. And this one was provided by Dawn Equipment. So on the right, you can see the planter that we used. It's got the coulter on in the front and then those spiked closing wheels in the back. All right, so the way we ran this experiment is we wanted to compare each different planter modification, so each component of the planter together with all of the other ones. And so this allowed us to try to see if there's any specific combination of treatments that really looked great, and it also gave us the ability to see how each one of these components performed in the context of all the other components as well. So just you can click the next button there. Yep, so the data that we collected then is we did kind of initial characterization of the soil nutrient status and the rye biomass, and Jessica kind of showed some of those numbers earlier in the presentation there for the kind of biomass that we were getting. Then around middle of July, once all those soybeans had come up, we went out, did some stand counts, tried to figure out what our percent emergence was. And then in the middle of August, we went back and did kind of a characterization of weed pressure. So just not looking specifically at treatments for this specific study, but just kind of generally across the field, what was the weed pressure. And then at the end of the season, we came back and took a look at our soybean yields as well. So this slide, I just want to talk a little bit about kind of how we've come with different planter uses from the past to where we're at right now. And we've used a few different kinds of planters. So starting in 2017, we used this AgCo planter, then moved to some of the planters that the Luck Lab had. And in 2019, the Luck Lab kind of fitted the planter with a better down pressure system and also some seed firmers. And so at the top here, the stand count versus our target populations in 2019, when we used that Luck planter with the updated down pressure and seed firmers, you're getting about 80% emergence of our soybeans. Whereas before that, in 2017, we were back all the way down to like 47% emergence. So this kind of is a testament to how important that planter setup is to get good emergence, and also kind of shows the progress that the Luck Lab has made as well. So Jessica or Brian, I just want to give you a chance to say anything more about the planter that you guys have, if you have any comments on that.
I can jump in a little bit, Ben. Yeah. Okay. So basically, there's a ton of bells and whistles on this thing. So if you look at we're doing downforce, we're doing automatic depth control. We're actually controlling the downforce on the closing wheels as well with an air system, although it's not necessarily. I think it's being actively controlled now that I say that. So we kind of like to say around here we specialize in the ridiculous. So we just threw the kitchen sink at the planter. But I think Ben and Jessica will get into it in a minute. There's some things that are great and do work and you probably really should consider. Other things are sort of nice to have, but not necessarily 100% necessary as well. So, but I have been really impressed on how much better we have been able to do using some of these technologies than what we were doing in the past. So
I think one good thing to note too about our planter is it is heavy. So the toolbar is filled with steel, which makes us really able to hit those high target down pressures that we're shooting for. And so we can talk about this a little more when we talk to the conclusions, but that's also something to keep in mind.
Yeah, real quick, we also got a question in the chat that I knew was coming. Any comments on the rolling seed firmer versus Keaton type? And I'm going to let Ben and Jessica talk about that. I've got my opinions, but I think I know what they're going to say.
Yep, yep. So, I mean, as you, I think as it's clear from this data that that was a big change that occurred. I wish we could give you a more concrete answer. I have a lot of suspicions that that plays an important role. So if you look in 2018 at the Luck Planner, we had the Keaton seed firmers on there. And in 2019, we switched to the Dawn Roper type seed firmer. And again, I wish I had the data, but I do believe that plays a role. So if you look at the picture down there highlighted in white, those are actually two soybeans that are down there. And you can see that excellent seed to soil contact down in the furrow. And that's those wheel type seed firmers. And so again, I don't have the data, but I have strong suspicions that that's playing a role in some of the improvements that we've seen. So answer, not answer.
Yeah, thanks, Jessica. I've been really happy with that roller seed firmer on the Luck Planner, and just looking at that picture, that's about as good of seed to soil contact as you can get. So I think that really played a difference in our experiments, just being able to get that seed tucked into the soil so well with that. Jessica, I think you can go on to the next slide. So taking a look at some of the results here. So I'll just draw your attention first to this table on the left side. So this is looking at soybean emergence percentage by the different planter modifications we had at each of our different locations. So along the left side, you can see all the different locations across the different years. We had 10 of them. And then anywhere you see a dash line, that means we didn't see any kind of statistically significant effect from having that modification. And anywhere you see a up arrow versus a down arrow, that demonstrates positive or negative effects of each of these modifications. So in terms of soybean emergence, we had 2 locations where we saw a positive effect of Coulter, where Coulter actually increased our soybean emergence percentage. And then in Marshfield of this past year, we actually saw the opposite effect, where no Coulter actually had a higher soybean emergence, and a lower down pressure led to better emergence versus a higher down pressure. And then in the soybean grain yields, we see kind of some of those mixed results as well. And so really what this is all showing is first of all, we didn't see a ton of differences between these different locations, and there's maybe a few reasons for that. We looked at those weather graphs earlier in the presentation, and we saw that in 2019, it was just a wet year. And when there's a lot of soil moisture, when we're getting a lot of rain right after planting, it's a lot more forgiving of a condition versus when we're going into a pretty dry year like we've had this year. So that might be some of the reasons why we didn't see a huge difference in some of these study locations. But I think it's also showing that really the ideal planter setup is going to vary from place to place. And so this is where it might take some work on your guys' end to figure out what's the best for your operation. Because a high clay soil in wet conditions is going to function very differently than a dry conditions with a sandy soil. So some of this is very site specific, but we did try to draw some general overall conclusions that I can show here in the next slide. And so when we looked at all the data together, what we saw that jumped out was that down pressure did have a statistically significant effect. So where we used a high down pressure setting, we were able to increase our soybean emergence by, it says 3% there, is closer to 2% actually. But we were able to get that effect there. Although this didn't translate to any kind of advantage in yield. And just if you can press the next button. So this is just looking now at each of those individual treatments, each of the individual combinations of different planter modifications. And again, really the only area where we saw difference was in that final emergence percentage. And generally it sorts out to the top with those where we use that higher down pressure, gave us that better emergence. And we saw much less of an effect with closing wheel type and Coulter. I think you can move on here, Jessica. So just kind of thinking what this all means. First of all, we saw a lot of variation between locations, and so that goes back to different weather conditions, it goes back to different soil types, and even possibly the amount of rye biomass that we have out in the field as well could all kind of influence what that best setup is. But generally speaking, we did see a good success with that high down pressure on increasing our overall soybean emergence.
Yes, before we move on to the next section, were there any questions we should pause or comments?
Rye has a question or a comment in the chat that he'd like to see a no-till plot comparison with a curse buster pass or two before after planting. I've heard of the curse buster, but I'm not real familiar with that tool. And if it's similar to a vertical tillage piece of equipment, Rye, feel free to unmute and talk if you want to, or Jessica or Brian. I'm just not real familiar with the curse buster.
I've not dealt with it much either, except in farm tech days. So it's a minimal till thing, kind of just pokes holes a little bit as it goes through. I don't think it stirs the soil too much. So, and I would
it's
agree. Go ahead, Ryan.
sorry.
Go ahead.
I have one. It's basically like a airway or gentil anyway. It's rotating it's got like 10-inch tines that basically go into the soil and push it a little bit to the side, but it doesn't leaves the mulch intact. This is kind of the thing about it that is interesting with the no-till and having potentially compaction issues is yeah, it doesn't disturb the mulch too much at all. And yeah, in dry conditions, it can be helpful. Also, it does increase some water movement upwards and you lose some. So if it's too dry, it can be a detriment. But I think in most years, it might be a beneficial tool.
I think that's a good point. Absolutely. If we can use some of those types of light tillage situations might help in this. That unfortunately wasn't the way we wrote the grant. We again, specializing in the ridiculous, we're trying to make this work without any tillage at all. So, but yeah, it would be something really interesting to look into in the future. That's for sure.
There's a comment in the chat too about preferring to roll or crimp the rye after seeding, so there's no bare soil. And you certainly can do that. I mean, there's two approaches to that, and one is to come through at anthesis and plant the soybean, and then come over again in a second pass and crimp. So you could do that on the same day, or you just don't want to time that at when that the beans are at the crook stage where those would be susceptible to damage. There's also the technique we've experimented with, which we come in and we plant the soybeans earlier on at the boot stage, which is typically about 2.5 weeks before the rye reaches anthesis, and then crimp over that, which varies in terms of its results, has some benefits in good years where that soybean does get a jump start. And if it's at about the V1 stage, when you do crimp at anthesis, the soybeans can withstand that crimping quite well. But if it's we found variable results and still a little unclear in terms of why that variability comes about. Could be because of cold, wet conditions after planting, and that those soybeans having trouble establishing under that cool, wet canopy. There could be other issues with predation or damping off diseases. But some years we see an advantage, some years we don't. But I mean, if looking at this photograph, some of that opening up of the row there, that can be adjusted, and correct me if I'm wrong, Jessica and Ben, and Brian, but that can be adjusted. So you don't necessarily see that degree of soil opening. And that is certainly unique with the Dawn roller crimper units. You wouldn't see that with the McFarland type model or the Rodale type model, but there are adjustments that can be made that can close that seed trench there, so that you don't see that rye moving away from it.
Yeah, I think I can jump in a little, Aaron. So the picture you're looking at, the two rows on the left, that was the dawn crimper, and we had the row cleaners on. And so this was for corn, so we were hoping to open up that row. And the right two rows, you can see there's very little visible soil. And with the McFarland crimper, you can do something similar. So the dawn crimper has row cleaners on the crimper itself, but we've done similar things with other rollers where you just put row cleaners on your planter, and you can achieve similar things if you're wanting to have a little bit of that opening for corn. But there isn't necessarily a lot of exposed soil if you are not using those row cleaners.
It's a really good picture, but not exactly what it's not soybeans. So
Yeah, it's corn. So,
there should, those open soil trenches shouldn't be there, or are not there in soybeans when we do it.
yep, exactly. So yes, I can move on. So Ben talked us through sort of what we can do as far as modifying the planter to improve hopefully stand-in yield. And I'm going to talk a little bit about, are there ways that we can use termination to improve our stand-in yields? And so we looked at two different crimpers. So on the top, you can see the dawn crimper. In the middle is the McFarland crimper that we used. And you can see our great mower and tedder here at the bottom. So the first year we had some difficulty transporting our mower to site. And so we had to use a handheld push mower, and Brian was always gracious enough to be our tedder. So we looked at these three options. So essentially two types of crimpers and mowing, and kind of to summarize sort of the big differences between the dawn and the McFarland crimper. So with the dawn crimper, you're actually actively applying force as you crimp. So you can kind of see the hydraulic lines there on the front, you actuate it down, and you're applying a lot of down force as you crimp. Whereas the blades are, you can see they're a little bit closer, a little shorter. With the McFarland crimper, you're actually just floating the crimper above the surface. So it is a fairly heavy unit. And so as it floats, it is applying some downforce there as well. The blades are a bit further spaced, but they're a bit sharper, I'll say, would probably be the best characterization. So they do both crimp quite well, but there are subtle differences between them. So we were hoping to look and see if this idea is crimping just crimping, or does having a different crimper matter? And then we also included mowing, just thinking that some people may have a mower and maybe want to try this, but maybe don't want to invest in a crimper. So just kind of seeing is that another option for doing this? And then the other thing we looked at most excitingly is flame weeding. So there was kind of this hypothesis that maybe just crimping alone doesn't provide enough termination. And so you can add flaming on top of that in hopes of improving that termination from crimping. We did not flame the mowed plots because obviously we terminated those quite effectively by mowing. So just a quick video to give you an idea of what this looks like. So this is a image from our UAV taken by a thermal camera. And so you can see the flames are lit, you're moving along, and you can see there is quite a bit of contact with those flames on the ground. And you can see that as the ground heating up, it's turning more of that red-orange color versus the normal cooler purple color of the soil. And so mostly what I wanted you to see is you can see those distinct lines where that soil is heating up and where that rye is heating up. And so again, our hypothesis is that maybe we could just improve termination by using the flaming.
Couple things to learn too. Can I interrupt, Jessica?
Yes, please.
Is your knuckle hair when lighting this thing does not exist very long. The other thing that Ben was impressed with was how the field voles out there do not like it. It gets pretty hot and they go scattering when we drag that over our plots.
So there definitely was an effect we were seeing. The one really challenging aspect of this is there were some years at some locations where we weren't able to do this because of the field conditions. So in particularly dry years, when the rye was very dry, we nearly started some fires. I think my boot soles got a little melty at a few times. So we don't have complete data on the flaming just because there were certain conditions that just made it difficult to achieve. So I'll talk a bit more about that later. And so we collected pretty similar data to what Ben talked about. So we did some soil sampling, we looked at stand counts. We also, depending on weather, did some UAV flights. Again, UAV flights are tricky because depending on weather, you need beautiful clear skies and low wind conditions to be able to get those images. And then finally, we did some weed and biomass counts in late August to sort of assess, did the termination strategy affect the weeds? And then finally, we collected yields. So a little bit on the UAV imaging. I don't have a ton of quantitative data, but I think it is interesting when you look at the UAV data. It is always very easy to pick out the mode plots, because if you look at those mode plots with the M, they're quite brown compared to the crimped plots over here. And so it is interesting that you do see these visual differences in the termination, and there could be some, pros and cons to this. So especially thinking about those dry years when you really don't want that cover crop taking up that excess moisture. So these flights were done a couple weeks after planting, and you can see there is still, so all that green is from the rye, not from the soybeans. The soybeans aren't really up yet.
We were just talking about that, Jessica, this morning at another meeting about how that could be an adaptive management tool. That means you would have two tools you would need. But in this year, like, was a very dry year, and exactly what you're saying, Jessica, that you can visually see it. And even though those crimpers are bending the vascular system, it's not damaging it so much that water still isn't pulled through the plant, and will stay green for up to 3 weeks after crimping. And during that time, it's still sucking up soil moisture. And years ago, I did do some soil moisture measurements under mode versus crimp plots, and you could see the continued declines in soil moisture in the crimp plots versus mode. You are physically cutting it, and the transpiration ends there. So in years like this year where it's dry, and you need to make a call of how to manage, you may want to go in and mow precisely for the reasons Jessica is describing. And it's interesting how much you can visually see that, but you can measure that within the soil moisture profile as well.
Yep. And I'll kind of, when we get to the conclusions, we'll talk about sort of like how to think about the pros and cons of each of these strategies. So there was a couple things we looked at. So first, we were interested in how did seeding rate affect stand? So essentially, I mean, as you can imagine, economically, the best option would be to be able to plant the lowest seeding rate possible and still maintain your yields. And so what we were hoping is that as we're getting better at these planting technologies, we can start to work on decreasing the seeding rate while still maintaining that yield. And so what we saw looking at those seeding rates, so I'm just looking at the two research stations. So Mars is that Marshfield Research Station, which is further up north and has very clay soils. And the Arlington Research Station, which is down here around Madison and has just perfect soils for growing soybeans. And so what we did see is that, if you plant more seeds, you get more soybean plants, which makes sense. Put more seed in the ground, you're going to have more plants. And so we saw that, that any line that has a different letter means that the stand was different. So we saw at Marshfield that we did get different stands by having different seeding rates. And we see that we also get different stands at different locations. So we saw higher stands at Marshfield, and a lot of that's due more to those weather conditions. It was very wet years, there's those clay soils, and so that germination was good there. However, when we look at yield, we didn't see an effect of that seeding rate on yield. So essentially, we were able to move to those lower seeding rates without having that impact on yield. And as we all know, that's a common effect in soybeans. You can reduce that yield, that seeding rate, and still maintain, within 95% of that yield for a given range. And so we did see differences in yield between locations, and a lot of that is most likely due to weed pressure. So one of these is not like the other. If you look at the left, these are some of our plots at Marshfield, and we see there is a very high level of weed pressure, which led to much lower yields. Whereas at Arlington, we were able to get a much higher level of weed control, and you see we have much higher yields at Arlington. And so once we decided that that stand count wasn't affecting yield, it allowed us to combine all of our data. And so when we look across all of those years and all of those locations, we did not see a difference in termination methods. So we had 3 years at Marshfield, 3 years at Arlington, and then a few different years on producers' stations. So looking across all of those, like essentially, if I wanted to make a general recommendation about growing in Wisconsin, I would say based on the data we have, termination doesn't matter. So it doesn't matter between the two crimpers we had or mowing, you're going to get the same yields. And that average yield was about, 35 point, my window of people are blocking it. Oops, sorry. I think it was 35.7 back there. Bushels per acre was the average yield. But there is a caveat here, is that we do see some differences in certain years and at certain locations. And so Ben and I, and Brian and Aaron and I have spent a lot of time recently thinking about why are we seeing those differences? So one example is last year at Arlington, we did see a difference, and we saw that mowing produced about 10 bushels fewer per acre than either of the crimping methods. And so our first instinct was maybe the rye biomass wasn't so high, or maybe the weed pressure is higher, and that could help explain some of that. So we look at 2020 in Arlington, where we didn't see those significant differences. We compared the rye biomass and the weed biomass. And we see that we've got a little bit higher cover crop biomass and definitely a higher weed biomass. So we started thinking to ourselves, like, okay, maybe that tells the story. Something was going on. We had those higher weeds, higher weed pressure, maybe was what made those differences in termination more evident. So I don't have all the weed data analyzed, but we looked at some of the 2019 data, and what we did see is that mowed plots did have more weeds than the crimped plots, but it wasn't, very rarely was it statistically significant. So essentially there's just so much variation in weeds and weed pressure among plots that it was really hard to say that there were actually more weeds in mowed plots than crimped plots. And that's also not to say that there isn't a difference. Maybe we just need more data, and maybe that is some sort of thing to keep in mind, is that it's possible to have higher weed pressure with that mowing. So we thought we had a good storyline, and we looked at another location where this happened. So at 2020 in Rock County on a producer's farm, we were looking and we saw that difference. And that kind of validated our storyline. There was a lot of weed pressure at that location. The rye stand wasn't particularly great. And what we see in this case is that dawn crimper was different than mowing, but the McFarland crimper wasn't actually different than the dawn or the mowed. So kind of that McFarland crimper was sort of in the middle, and we had higher yields with the dawn and lower yields with the mowing. And you see it's actually over a 10 bushel per acre loss there. So then we thought, okay, well, maybe the weeds can explain it all. And so we looked at another location that we knew was very weedy, which was Marshfield. I showed you that picture earlier where there was just tons of weeds in the plot. And we're like, okay, surely if weeds are the issue, then in this location that is consistently weedy, we should see differences. But we don't. There is a numerical difference in the mowing for the yield. Oh, sorry. There is a numerical difference we see, but it's not statistically significant. And so I guess clearly I wanted to take you through this and just say that we don't have all the answers yet. So if we look at all the data combined, we don't necessarily see a difference in the termination method, but there are certain years and certain locations where it does make a difference, but we can't yet fully explain that difference. And so before I make some conclusions too, I also want to bring up a couple challenges that we're still having. And so Ben talked about how with the planter study, we were looking at different types of closing wheels, and he didn't really see a big effect. There were some locations where it mattered, but the challenge with these aftermarket closing wheels, which it's hard to see in this picture on the right, that is an aftermarket closing wheel because it's so wrapped up in rye from just a single 80-foot pass of planting that it's essentially no longer functioning as a closing wheel. And so in our experiments, we were able to unwrap that at every plot. But as a producer, you're not going to stop every 80 feet and unwrap your closing wheel with rye. And the other issue we run into a lot, especially in plot work, is always making sure that you're crimping in the same direction. And so that can be something that can cause a challenge at planting if you're always trying to plant your field while crimping in the same direction. You can run into these issues where essentially the rye gets bound up in the crimper, and that can lead to bare spots within your fields, which can lead to much higher weed pressure. So there are kind of these pros and cons to think about. So I guess wrapping up, really what we saw is, looking broadly, termination method didn't affect it. But I think there's a few things I really want to think about with us today is, mowing for the most part is mowing. And I guess I will say the one caveat is we were using a sickle bar type mower as opposed to a flail type mower. Having that sickle bar mower leaves much longer pieces of rye intact and act as a better mat. I don't think we would have found the same results with a flail type mower, which is why we chose that sickle bar type mower. And while we didn't see that much of a difference between the two types of crimpers, I think there is room to start exploring optimization of crimping. And if we are able to optimize that crimper, that may set crimping even further apart from mowing. And so kind of, I guess, maybe the experience we've had shows that, maybe there isn't a difference, but there are times when maybe you want to consider one strategy over another. So looking at those images I presented, thinking about in a very dry years, it may be beneficial to do mowing and help preserve that soil moisture. But knowing that that comes at a risk where, for reasons we can't fully explain yet, you could have a pretty significant drop in yield by mowing. Whereas other years, we didn't see an effect. So I would say that it is a strategy that you could potentially use, but possibly with caution. I guess thinking about the strategy that's maybe more likely to reduce your risk, crimping seems to be less variable over the years. But again, I think there are so many site-specific effects that really, with the planter and the termination method, it's really important to explore these at your farm and see what's working for you. And so I guess with that sort of somewhat unhelpful answer, I'll turn it back over to Ben to talk about what we've been doing with corn, unless anyone's got some pressing questions.
Just to interrupt quickly, I put it in the chat, but I'm going to have to bail off to go to another meeting. So thanks for the time. And if anybody has any questions, feel free to contact me or Jessica or Ben or whomever, and we can get back to you. So nice
Thanks,
job.
Ben.
Thank you.
All right, thanks, Jessica. Can you go to the next slide here? And I see Lyle put in the chat asking about our corn and clover plots, and that's just what we're going to talk about next. So one of the really exciting applications of doing this reduced till organic systems is trying to figure out how we can make this work in corn, to start working to develop more longer term reduced till or no till kind of systems in organic agriculture. But with corn, there's a lot of challenges, probably even more than with doing this in soybeans. And so what we're really looking at in a set of different experiments here is how can our cover crop management be used to address some of these barriers we see to reduce tillage organic corn. And those barriers are partially going back to planting and getting good emergence, but also there's some interesting nutrient dynamic things going on as well that need to be addressed. So Jessica, will you advance on here? So I'm just going to go over a couple of different experiments that we use that are getting after this optimization of reduced till organic corn. So the first one is basically the exact same thing I talked about earlier. This is looking at different planter modifications, only instead of doing soybeans into a straight rye stand, here we're looking at corn, no-till planted into a rye and hairy vetch mixture. But our treatments were just the same as what we did in soybeans. We had those 2 levels of downforce, coulter versus no coulter, and a couple different kinds of closing wheels. Second experiment is basically the same thing that we did that Jessica talked about. So we're looking now at termination type in a rye and hairy vetch cover crop mixture. So we had those 2 different roller crimpers, the McFarland and the Dawn crimper, and we compared that against mowing. Then we did a flaming also at termination. And we had an in-season management as well. So we used a tool called an inter-row roller crimper that it has these individual roller crimper units that through hydraulics, you can either widen it or shorten it. And that allows you to go over the field once the crop is already established without harming that corn. And so we wanted to see if that had any effect on maybe doing a better job of terminating some of that hairy vetch and rye. And then the final one, here what Lyle was alluding to in the chat was our corn planted into medium red clover. And this one was a little bit more management intensive. And so we kind of divided this up into a few different operations throughout the season. So we had a pre-plant treatment where we did an undercutting versus a not undercutting. And so what I want to mean with undercutting is basically this is kind of a less aggressive form of strip tillage. So we have these sweeps that dig into the soil only about maybe 2 inches to 3 inches max deep. And it really just kind of cuts off those clover roots and terminates it within the row where we're going to plant the corn. And also it gives you a little bit more of a furrow, some bare soil, warms up a little bit faster. And we saw that corn get out of the ground a little bit quicker where we had that undercutting as well. Then after planting, we did a flaming versus no flaming kind of treatment to see if that would impact our termination and also if that had any effects on weed control. And then later on in the season, this is about a month after planting, we went through with a high residue cultivator, compared that to our inter-row crimper again, and then looked at a combination of both of those together.
I was just going to note that it's the same implement that does the undercutting as the high residue cultivation.
Yep. I'll have you go on to the next slide here. So just talking a little bit about how we manage the system. In the rye and the hairy vetch, we planted 70 pounds of rye and used 40 pounds of hairy vetch to mix in there. And important to get this in early, so we tried to get this planted by middle of August. Then about the second week of June is when we were able to get out there and terminate that vetch and rye mixture. And also about 2 weeks after planting, we went in there with some pelletized poultry manure and put 2 tons per acre down there as well for some added fertility. And then moving on to the red clover system, we put 15 pounds per acre of red clover out there. Again, important to get this in early to give that time to get that biomass in the fall. And so again, we went out there in mid-August to plant that. The management then we did in season is, I already kind of touched on this. We had that undercutting pass before planting. And then every plot we went through and used the inner row crimper about 2 weeks after planting, just to try to knock that clover back and give the corn a bit more of a start. And then a month after planting, we kind of divided up those treatments a little bit more. So we compared the inner row crimper versus the high residue cultivator as well. So moving on to look at some results now. This is looking at 3 different field trials. So 2 locations across 2 different years. And what we saw when we looked at all this data together is we did increase our corn emergence by 7.8%, where we did use that coulter. This didn't impact our yield at all, but seeing that higher emergence is definitely something that we were excited about. And we didn't see any impact on closing wheel or down pressure here, looking at that. Jessica, if you could move on. So looking again at each of the individual treatments here, we see differences in our plant stand and in our emergence. And again, this sorts out with those treatments that had the coulter, those kind of sorted to the top as being the most successful, whereas down pressure didn't really have any effect at all. And we did notice some interesting dynamics going on between our coulter use with our rubber closing wheels versus with our Dawn closing wheels. And so if Jessica, can move to the next slide, that'll show a little bit more of this. So in 2020, we actually saw a 22 bushel per acre increase in our yield, in our corn yields, when we used a coulter paired with a standard rubber closing wheel. And so this graph on the right, if you look at that blue line there, that's showing our data where we had the coulter and the standard rubber closing wheel. And it's looking at corn yield versus plant stand. And so we see that kind of expected correlation. As we get more plants out there, we would expect to see higher corn yield as well. And that's what we see in this combination. But where we use that Dawn roller crimper and paired that with the coulter, we didn't see that correlation. So that's indicating that there's some other kind of dynamics that are going on that are maybe not getting us that same yield that we got with the standard rubber closing wheel. And perhaps that goes back to that really great picture Jessica showed with the wrapping of that rye and vetch around those aftermarket spiked closing wheels as well. So we're going to continue trying to look into this a bit next year. We're going to run the same experiment and see if we see the same trends or different trends and see what kind of conclusions we can make from that. Jessica, if you can move on, we'll talk now a little bit about our corn planted into clover and just some preliminary results we got there. So looking at this figure here on the left, this divides out all the different in-season or all the different management approaches we did to manage this. And where we saw the big difference was where we undercutted versus not undercutting. So having undercutted those plots gave us this year a 50 bushel per acre increase in our yield. And then we didn't see as much difference between flaming, and our in-season management also didn't make a difference in yield. We did see a difference in weed numbers with flaming, which is interesting. I don't have that data presented here, so if we get a chance sometime in the future to talk a little bit more about that. But that's another interesting component that we continue to look at as we go into next year. So overall, we were pretty excited with the results that we got from doing this experiment this year. With that undercutter getting all the way up to 135, nearly 140 bushels per acre was a success for us. But I think we also need to take this in the context of some of the previous years where we've tried this, where we haven't gotten nearly those yields and where we've had some challenges with this. So we're going to continue working on the system, trying just to get better consistency in getting high yields like this as well. Jessica, have you?
I was going to, can I jump in real quick? So I guess I also want to throw a few caveats in this study. So this wasn't a conventional field that we managed organically. And so that weed pressure was a lot lower than we've experienced in the past. And the other kind of caveat I want to say is that this year was quite dry at planting, and the undercutting operation definitely disturbed the soil a lot more than it has in other quite wet years. And so I think that I want to say that like we need to do this also in wet years to be as confident that we'll see such a difference based on those soil moisture conditions. Essentially, the sweeps just operate a bit differently. When it's very wet, it just kind of like cleanly slices the roots, and it seemed like the clover was more likely to grow back, whereas in those really dry conditions, it really disturbed the soil and was a bit more effective at removing that clover from the rows.
Yeah, thanks, Jessica, for pointing that out. Yeah, so looking just kind of at some general conclusions we can make from this. So we saw that increased emergence when we used cultures with our corn, and also some of those interesting dynamics going on between closing yields that we'll continue to look at as well. And then again, we were excited about the results we saw this year of planting corn into clover, but as Jessica mentioned, it's just 1 year and a lot can change from year to year. And so we'll have a lot more work to do to really understand what's going on in these systems and how to optimize it. So I think that's all we really have to present today. I guess we can go to the chat and take a look. Ben
There's a couple
Jenkins is
questions
asking-
about the relative maturity of the corn variety and size of the sweep for the undercutter.
Mhm. Yeah, I can talk about the sweep size here for the undercutter. The sweep was about 8 inches wide. Does that sound right to you, Jessica? And it really left about 6 to 8 inches of disturbed soil between each of the rows.
I was going to say it was like a 6-inch sweep. So I think
Okay.
6 to 8.
Mhm.
And the maturity of the corn, do you remember? Is it's a short season corn.
Yeah.
85. I would have to check. Like 85 is popping out to me, but I'm not. I should know that.
There's a question about the planting depth for the corn, for the no-till corn.
Yep, so we target about 2 inches, which sometimes can be a little difficult. I think that is planting depth is definitely a big challenge we have for a few reasons. I mean, essentially we were planting as deep as our planter will go. And so at that high down pressure, we're able to achieve that depth, but sometimes with the lower down pressures, we weren't able to achieve that depth.
I see a question here about planting date and soil temperature. So we tried to get this planted in the second week of June. I think this year was June 8th is when we got out there and got this planted. We don't have any data on soil temperature, which would be interesting. And I did mention that I noticed that corn did get out of the ground a lot quicker where we had that undercutting just because of the bare surface of the soil. They're warmed up a little quicker. So there is some dynamics going on there for sure. And the question here, did the clover stay green all summer? It really did. It was continuing to grow. And that's kind of why we went out there with that inner row crimper to knock things back at a couple different points. And question on pests, Jessica, would you like to talk about armyworm at all?
I know that's such a hard one. So because this is research and our plots are like so valuable to us, we're very risk averse when it comes to pests. I mean, I know everyone's risk averse, but I think we are especially so. And so we did have a limited number of armyworm, and we did choose to treat the plots with Entrust. I mean, it's hard to say, like, would it have caused damage? It's hard to say, but that definitely is a risk with that rye vetch system is armyworms. And that's definitely something to weigh. I think especially in really high weed pressure situations, that medium red clover just honestly doesn't cut it. It's just not, it is not dense enough to be a very effective weed suppression. Whereas that rye vetch mixture is much more effective at weed suppression. And so I think there's not a simple answer, unfortunately.
I've been told by entomologists that even though we're seeing the armyworms in the field, they may not cause economic damage, but can't really give a definitive answer. So as Jessica said, we've been proactive of spraying in trust so that we can ensure that we're getting a research plot at the end of the season, and trust is something that is allowable in organic systems, and certainly could be used on a production scale as well. But obviously organic insecticide inputs are not cheap. So something to weigh when you also look at the struggles with maintaining yield potential in these systems. And you answered the question about the clover staying green all summer. It does in these systems. We've talked about trying crimson clover, but I don't think, Jessica, I'm trying to remember if
Oh, that was not that. So
it worked for us.
crimson clover was very effectively terminated. I will say that essentially at planting, we killed it. And then we had no weed suppression. We ended up having to just terminate those plots early due to really intense weed pressure.
And yeah, Aaron is asking about the cost of interest. I can't remember. I know I've calculated that out in terms of cost per acre. And you do, at least I've been recommended, again, we haven't done side-by-side trials to see what the what would be an ideal rate or timing as well. But we were advised to use in this situation the highest label rate. So of course, that's going to bring the cost up as well. But I'll try to get that to you, Aaron, what the cost is, and maybe a link to that product. You could also use spinosad as well, but or Entrust is spinosad. I'm thinking of BT. You can use BT as well, and that would be another option. And BT, I think, tends to be a little less expensive, but BT, I think you need to use at a bit of a younger stage of the larval growth. Rye, do you want to unmute and talk about, you have a ton of experience in doing different things with no-till corn. If you want to unmute and talk a little bit about what you've tried.
Oh, okay. Well, 2 years I planted corn no-till into rye and just put a lot of manure on it, and it got rained in luckily. And it kind of worked out okay. High population, but it's way too late to plant corn up here. And
You're in northern Minnesota, even just almost at the tree line there, the forest where it starts to get
Yep.
from ragland to forest. So just for context, you're definitely in a northern climate.
Yep. But yeah, I did have, seemed to be quite a bit of pest pressure when it was young, but if it, it generally grew through it. But yeah, I've definitely moved away from, it's a big roll of the dice, especially on getting a good amount of rainfall to get the manure in the ground, basically. So I've moved away from that completely. But yeah, I'm doing a buckwheat interseeding at V1 now and making a interrow crimper to smash it when the corn's maybe 3.5 feet tall. I've done that last couple of years without crimping it, but in the drought, spiking corn gave the buckwheat too much sunlight. So I think the safest thing to do is to crimp it. Yeah.
Thank you. The buckwheat corn is a interesting system. I know I don't think Paul Hoffman's on this call today, but I know he's tried some interesting things with buckwheat and corn as well. And Michael O'Donnell, if you want to unmute and talk about your experiences down in Indiana.
Yeah, hey, can you hear me?
Mhm.
Yeah, so I work with a farm in Northwest Indiana, about halfway between Indy and Chicago. And we tried some new techniques on 600 or 700 acres of organic popcorn and just one little field of transitional corn, which we wouldn't usually do. It was kind of a weird situation, but I call it quasi strip till. Some of it was kind of true strip till. Probably 100 acres was true strip till. It was all into stands of alfalfa and clover. It'd be vernal alfalfa, just cheap stuff, and mammoth and medium red clover. Some of them were 2 years coming out of transition. Some of them were just a single year stand. And so our technique was let that clover and alfalfa go quite a while there in the spring. And when we were ready to plant, we ran over it all the way down to the ground with a flail mower. We got 30-foot Henniker flail mowers, so we can move fairly quick. And then went through the field with a Henniker single sweep cultivator, and I forget the share lengths that we used, but it was basically what you were doing, Aaron, with these plots with undercutting. And that's essentially how we made a strip. And if anybody's going to do this, I really encourage you don't get lazy with changing out sweeps. Because they get dull, and when they get dull, the thing's not setting down and undercutting very well. And then, so then we'd plant these strips, but on most of the fields, what we noticed was that when we do the undercutting and kind of blow out the strip, so it wouldn't be really ideal for planting right into it. And we were concerned about, really aggressive regrowth of the alfalfa and clover between the rows. Since this was popcorn, a little slow to get established early. What we did was just run really shallow, kind of at a diagonal to the strips with a limpkin. I think it was the limpkin Reuben that we used, just skimming the surface, kind of chopping up the alfalfa and clover. And then more importantly, smoothing out those strips that we made with the Henniker. So I call it quasi strip till, but some, like I said, about 100 acres, we didn't do that. Before we'd run over the field, entirely over the field with that limpkin, we'd go over with the planter to get an AB line. So we'd be planting into those undercut strips. And so this would all be turned over in a day. We'd go from a solid lush stand of alfalfa clover, flail mow it, strip it, hit it with the limpkin real shallow, and plant it all on the same day. And there's no manure. We didn't put any manure down. It's planted. We did play around with some liquid and some dry stuff with planter, but didn't see any yield response in the end. As things got going on some of these fields where the alfalfa regrowth was aggressive, particularly we didn't go over with the limpkin. We actually hit it again with the flail mower when the corn was really small, just to shred the stuff back between the rows. Elsewhere, and moving forward on that field, we used Williston cultivators to kind of suppress the alfalfa and clover between the rows, just essentially buying days for the popcorn to keep coming on. And then at some point, it's like the popcorn was getting into that rapid growth and started to become the more dominant plant in the field. And then prior to canopy closure, we actually did go through with the Henniker and undercut between the rows, but we still had quite a bit of alfalfa and clover out there. at the end of the season. We ended up with decent, with good yields. We're happy with it and going to continue to modify and improve on the success that we had this year.
Thank you for sharing, Michael, and thank you for sharing too, Rye. I don't know if I thanked you after you
And-
described what you were doing. So do you think that
something else real quick to consider? This sort of built on a very minimal tillage approach with alfalfa and clover the previous year. And so this starts to get to this idea of thinking, systems thinking and thinking out multiple years on one of these fields that we did minimum till in 2020. Very similar, except we didn't do the undercutting. The next year we seeded, or that fall we had seeded it to rye for no-till soybeans the subsequent year. We ended up having a lot of alfalfa come up with our soybeans. And so it was a very interesting management, adaptive management year for that field of soybeans. We learned some things and pulled off, an okay yield of soybeans on that field. But it's something to think about. If you're going to try this, you're likely going to have some alfalfa still coming through the subsequent year. So trying to go no-till soybeans after this minimal tillage, strip tillage type of corn system could be problematic.
So do you think one of the keys to having this work was also doing the undercutting in the row to suppress the alfalfa? Yeah, that's what I would get. I mean, I think suppression is really key to these systems. So how do we, and even if there is some rerouting, how do we cut that root system enough to minimize the depletion of soil moisture and minimize competition? Has anyone else had any experiences with organic no-till corn, good or bad, or even with soybeans as well, good or bad? I do feel like we're continuing to make progress. I think the suppression is key. I think delivering fertility is key. We had an interesting meeting this morning that was more specific to some of our research, and not only looking at potentially nitrogen early on to fulfill the nitrogen needs of the corn, but also thinking in these systems with cooler soil, or potentially looking at a higher seed-end ratio, even with the roots or carbon additions, that nitrogen potentially revving up the soil biology. So kind of a combination of stimulating biology, which is going to release other nutrients as well as delivering N to the corn. And we've, and Brian and I talked a little bit about this morning. Brian and or Jessica and Ben haven't heard about this yet. I think Jessica, you and Brian talked a little bit about this. And we've been using composted poultry manure, and we have not tried in these systems, although we did do some work with soybeans this year using different starter fertilizers, whether it be feather meal or Chilean nitrate. We didn't see any differences with soybean this year with the different starter fertilizers, which have differences with respect to both, percent N within the product as well as N availability. But if some of the impact is stimulating soil biology, we were applying it on such dry fields. I wonder if we were kind of hampered with respect to that benefit of those starter N additions. So yes, when we look at these corn systems, whether feather meal or Chilean nitrate might be a more appropriate way to, again, not only deliver N initially, but potentially stimulating some of that soil biology. And I think that's one of the reasons why we see such a, further along in success with the soybean systems, is that not only they're a legume, they're really an efficient legume with respect to symbiotic rhizobium bacteria relationships. And Rye's asking about foliar applications. Yeah, I have not seen a lot of data in terms of foliar applications. I've seen that for soybeans. I think which is one of the things that we're trying to understand with these experiments, nitrogen fixation tends not to kick in later in the season. And, if you've ever done rolled rye soybeans, you can see, that those fields lag until about the latter part of July, and then you can see those fields green up and the soybeans tend to catch up. So, one of the reasons why we were thinking of starter fertilizers was until that nitrogen fixation really kicks in, is some of that yield drag that we often see in the system due to effects of low nitrogen uptake earlier in the season. So foliar applications, my understanding of those is that they tend to be more effective with respect to micronutrients versus nitrogen. And then Bruce put in there Blue End. We were going to try that last year, but I thought that there was some issue with availability. Like the product was owned by a smaller company and then it was sold to a larger company. I want to say Monsanto, but I don't know if that's correct. And there was an issue with getting it, but that may have changed, or I think there was some of the product that was still available from the previous company that had the rights to the product. Yes, it's out there. Yeah, so it still might be out there, but whether or not it's the longer term, what its availability is, and particularly its availability in organic systems, because if it's owned by another company, there may be some changes in formulation or the process in which it's produced that may impact its availability in organic systems. Bought out by DuPont. Yeah, I knew it was one of those bigger companies. So not Monsanto, but DuPont Corteva. Thank you for the clarification. But yeah, I was curious too about that Blue End product, because anecdotally I had heard some really positive things about that product, but it was maybe I'll still try to see if we can kind of get some that's still kind of hanging around there. But yeah, I think that in terms of a foliar might be more effective with respect to the N issue. And Blue N is something, correct me if I'm wrong here too, it is involving kind of more free living nitrogen fixing bacteria. So it still is a bacterially driven process, but it's more foliar. Yeah. Mark, you can unmute, Mark, if you want to talk to about your experiences or some of the products that you might have used.
Well, we've done a lot over the years, but I guess on the corn side, everything we've done has made us just a bigger believer in Chilean nitrate liquefied 2x2 with the planter. And if you can't get the nitrogen to go your direction in the first 3-4 weeks of a corn plant's life, personally, I believe the yield game's over. I don't care how much you can catch up later. It never does. So I think that nitrogen up front, as much as the industry has a love-hate relationship with Chilean nitrate, I think in a corn situation, if you want to maximize your yields, that's your biggest bang for the buck. So I don't put Nature Safe and all these other feather meal, blood meals and stuff in the same category, because it seems like that takes biology to release. Now, there certainly is a difference between liquefying Chilean nitrate, which, by the way, is very easily done with an air compressor and a cone bottom tote. So it's not a big deal to make your own liquefied Chilean nitrate out of a 2,600 pound bulk bag. But you can also put that material on dry and then maybe, based on soil moisture, get a controlled release of Chilean nitrate. But we've always wanted the immediate bang in the corn crop. So we've tended to liquefy, plus we weren't really set up for dry either. But those are the things that we kind of liked on the corn side. On the bean side, I guess for us, what was helpful was humates and really stimulating the rhizobium to take off. So those are the two things out of everything that we've done. I guess we've given up on stripping and those types of things with the vetch that we have. We pretty much have to terminate. And even the medium red clover, with double stripping with the Dawn system, again, just kicked our butts. So I guess we're seeing light termination with some sort of disc system. It doesn't have to be perfect, but to get that nitrogen release and get things headed the right direction. So those are our takeaways on what we've seen.
Thank
But
you. I know
it's-
you've done a lot of innovation on that front. Kurt's asking how much Chilean nitrate per acre and how many pounds of nitrogen do you know that's the equivalent of?
Yeah, 9.6 pounds of nitrogen. It seems insignificant, but Reginald Dustry talks about, a 7-time multiplier, and I guess I believe that's correct also. That's 60 pounds of product per acre. I believe it's 3 pounds of Chilean nitrate liquefied into 1 gallon of water. So anyway, it's 9.6 units of N, or 60 pounds the acre, dry basis.
Thanks. Yeah, I know that just if I'm hoping we might try Chilean nitrate too. So I don't make this comment to dissuade people from trying it, but just make sure you check with your certifier, and especially if you know that product's going into export markets that that can impact the sales of those products. I think Canada doesn't allow for Chilean nitrate to be used. Thank you, Mark. Other questions or comments on what people have seen with organic no-till corn and soybeans? That's a really interesting observation to Mark, or comment that, again, looking at some of these micronutrients or value of these other products to stimulate the rhizobium bacteria and the biology, as much as looking at delivering directly those nutrients to the crop. There's so much we still have to learn about all these interactions. I know I was thinking too at one time it'd be cool to do some experiments, because I know that there's thinking similarly. I mean, humates, I guess there's similarities to compost, that we see a lot of benefit to compost, even though that there's not a lot of nutrients in that product. But I wonder how much that compost, the benefits we see is really the benefits of soil biology and the subsequent nitrogen or nutrient cycling that is a benefit of the enhanced biology, versus the compost itself as directly benefiting the crop. It's really going through the biology that is the critical part.
Yeah, and I'd like to know from just the humate side, if it's simply moly. There's 80 micros and things in humates, but moly is required, is my understanding, for not the mycorrhiza, but I'm sorry, the other term for the soybean nodule is required. So I guess I wonder if it's that simple, or if it is just simply microbe candy. What is it about humates that's driving it? Because it does contain both. And I guess moly, the word I couldn't think of was rhizobium.
Yep,
Moly is
exactly.
required for rhizobium, not for the soybean plant itself. And I think that's the exciting thing, is we find out, what microbes need versus so much about what plants need, and focus on the microbes. There's a lot of evidence that just suggests, support your microbes and you'll have your crop. So maybe we've been looking at the wrong thing. I'm not sure.
Well, we're right about at 1:30, and maybe that's a good comment to end on. We'll certainly be doing more of this work this summer, and having a field day out at Arlington again. And if any of you want to come see what we have going on, And yeah, I always appreciate hearing how these systems are working on farms and what sort of innovations people are doing. So thank you, Ben and Jessica, for putting together all that data and presenting today. And thank you all for joining us and contributing as well. And we will maybe see you guys in a couple weeks. And if you at the Moses conference, definitely look me up. So have a great weekend, everyone. We'll talk to you all later. Bye.